Okay, ladies and gentlemen, how are you? Welcome back to my second video on demo 1 to cover features 5, 6, 7, and 8. So before you come to this video, you have to uh, go through the first video where I shared on the features from 1, 2, 3, and 4. So now we are using the examples of coffee maker machine, which is model SEMA and model Pro. The difference between these two models are their main materials for their body and also the system that they use to keep the coffee warm. All right, so in the first video, we have inspect the goal and scope, we inspect the processes in database. We also tried to analyze one coffee maker machine to analyze the environmental profile, and then we generate a process network, all right, from the product of the coffee maker machine. Okay, so now let's continue. So in this video, I'm going to show you how to analyze a full life cycle, and we compare two products in their production stage, and we compare their life cycle, and then we inspect or select a method. So let's start. So to do that, we have to open the project. So we click on the file and open that project. And this project is actually the introduction to SEMA Pro, and then we open it. Okay, so in this case, let's see. So number 5, we have to analyze a full life cycle. So to analyze a full life cycle, everything is already inserted for you. So you just need to come to product stage and then click on it. And then this is where the full life cycle is. You click on this and then it's already inserted for you. So you have it. So there are two life cycle model here. So life cycle model SEMA, plastic, life cycle Pro, which is aluminium, no tech back. Okay, sorry. So it includes the disposal, means the disposal scenario of this, because life cycle means the processes is included from raw material to manufacturing to use and to waste disposal. So let's inspect what is it in. Okay, for this one, let's click on it. So when we click on it, if you look at this one, this life cycle include the assembly, means the product that we have inspected in the first video. So SEMA Pro, assembly model SEMA, 1 unit. And then during the processes or during the usage throughout the time frame of 5 years, the total electricity used is 375 kilowatt hour. And then on disposal, so it consider household disposal, which is described. So we can have the comment, see the comment. So this waste scenario describe how household waste is in the Netherlands is processed. This includes source separation performed by citizens such as paper and glass, and then collection system and waste treatment by average Dutch municipality. So means they assume that this coffee machine will be handled by the municipality. So normally they will be recycled, separated at material recycling facilities. Then after that, the recyclable material will be separated out and being recycled, and the non-recyclable material will be thrown into landfill. So some other additional life cycle that they include is the use of coffee filter and then the use of packaging. All right, so they include this coffee filter and packaging there. All right, okay, so this is the whole life cycle of it. So let's analyze a full life cycle. So to analyze, so click on this analysis, and then we are very much interested with carbon emissions, so we choose greenhouse gas protocol. So we choose on it and then we calculate. All right, so okay, so now you will notice that the categories. Okay, let's look at the table first. So in greenhouse gases, they always consider 4 impact categories. One is fossil CO2 emission, one is biogenic CO2 emission, so CO2 emission from land transformation, and lastly CO2 uptake. So, okay, so CO2 uptake. So let's look at here. So they consider 5 processes. Okay, first one is the assembly, which is a total model SEMA plastics. The second one is the electricity from the electricity use consumption throughout the lifetime of this small coffee maker, 5 years. And then the waste disposal part. And then when they are using this coffee machine, they need to use coffee filter. And then the use of packaging when the coffee machine is being delivered to the users. So basically, there are 5 main processes, all right, in this life cycle, or 5 main component in the life cycle of coffee maker machines. So in this case, it will tell you the total CO2 emissions and then the total biogenic emission from all these 5 components of life cycles, and CO2 uptake and CO2 from land transformations. If you look at the graph, all right, so for CO2 equivalent from land transformation, there's no data to support it, and hence it is 0. So if you look at the other 3 CO2 emissions and CO2 uptake, you will notice that yellow color, which represent the use of coffee filter, is the main contributor to biogenic CO2 emissions and CO2 uptake. All right, so on fossil CO2, the light green contribute the most, which is the electricity generations. Right. So in this case, we can tell that if you are an eco designer of the coffee machine, you will look into the electricity consumption of your coffee machine so that it will consume less electricity, and hence the life cycle of your coffee machine will be less impactful to the environment. And then, of course, you will consider to maybe replace coffee filter, or you do not need to use coffee filter at all, because we know that coffee filter is generating a lot of carbon emissions, okay, on these 2 impact categories. While the use of packaging is only contribute quite a little, and the assembly of model SEMA Pro, which is the dark green, which contribute quite little as compared to the other component. So now we analyze a full life cycle, so we can tell, we can have a description, we're able to draw conclusion on what component of the life cycle contribute most impact to the environment in terms of carbon emissions. Of course, you can do a network like we have learned in video 1. We can do a network. So it will tell you for life cycle, if you see the arrow, they are go up, they're going up, they're coming down. So let's zoom in. So life cycle, you will have assembly of model SEMA contribute to the life cycle. Life cycle means that normally for a layman, it represents usage. Okay, so when you want to use the product, you need a plastics, I mean the product coffee maker machine to go into the life cycle of it, electricity to go into the life cycle of it, and then when it comes to the end of life, then the waste have to go out. So there's an arrow coming down, and then the use of coffee filter will going up, contributing. So this is an input, this is an input, this is an input, where the waste is an output. So it will coming out to here. So this is how this SEMA Pro software present the network. All right, of course, in video 1, I've shown you how you can change to biogenic emission. Okay, so it will give you another network. So which one is contributing mostly to biogenic carbon emissions. Okay, so on inventory plot, so it will tell you on the substances that contribute. So in this life cycle, it quantify about 567 substances. On the process contribution, there are more as compared to video 1, where we are only considering the assembly. Now on top of the assembly, we also considering the electricity generation. We also consider the waste disposal method and all activities that support the waste disposal method. We also consider the coffee filter production. we also consider the packaging production. So, and hence there will be more processes contribute to this life cycles. Okay, so it's shown here. All right, so that is number 5. We analyze a full life cycle. Of course, we can analyze it separately. Plastic, the model SEMA, we can analyze separately model Pro. So on number 6, I'm going to show you now how to compare two products at the same time. Okay, so let's say we like to compare, okay, the two products in the production stage only. So in the production stage, because production doesn't mean life cycle, we have to go back to the assembly. So in the assembly, we have two production stage. One is model Pro assembly, one is model SEMA assembly. Okay, in video 1, I've shown you this how to analyze the profile of model Pro alone. So now I'm going to show you how to analyze them concurrently. It means to compare. So in order to compare, so I have to double click. When I click on it, I hold the keyboard control and I click on the second one. So I highlight these two processes. Okay, I highlight these two processes. Instead of clicking analyze, I click on compare. So it comes to the same page. So when I click on compare, it will help to choose these functions. Okay, so you will notice that in the product, instead of one process, now there are two processes appear here. So means I'm going to compare assembly of model Pro and assembly of SEMA. Okay, so when we are doing comparison, it is very important that it is a fair comparison. So here, it has to be one unit to another unit. If let's say I change it to 5 units, so it is a bias comparison, for sure, when the result shows, it will show higher impact on model SEMA. Okay, so when compare to get a fair comparison, I have to make sure that it is an apple-to-apple comparison. Yeah. So now the method. So we are still sticking to greenhouse gas protocol for simplicity so that we can see. Okay, now once we choose this greenhouse gas protocol, we just click on calculate. So if you look at the graph, the chart, all right, so there are still 4 impact categories of greenhouse gas protocol, but instead of showing you 1 bar, now this is showing you 2 bars, where the dark green represent the assembly model Pro aluminum, the light green show you assembly model Pro model SEMA plastics. So in this case, let's analyze. So to produce aluminum coffee maker, it generates more fossil CO2 equivalent as compared to plastics. So the higher the percentage means the higher the value it is, the impact it is. So it's not good to get high value, all right? So because LCA is life cycle impact assessment, so it assess the impact. The higher the value, the worse it is. Okay, so in terms of biogenic CO2 equivalent, so aluminium is less environmental friendly as compared to plastic, which is in light green. In terms of CO2 uptake, so plastics have more CO2 uptake as compared to aluminium. So by looking at this result, one conclusion that I can make is it is better to produce a coffee maker machine with plastics, because aluminium, it generates too much carbon emissions. Okay, so if you are doing comparison, you will notice that there is no network button here, because it's impossible for the software to create 2 networks at the same time. So when you are doing one analysis, then you are able to create the network. But when you are doing comparisons, it's not possible for you to create a network. So on the inventory, you will see, okay, these are the substances. Same thing, they are analyzed 570 substances. They are comparing this assembly model Pro, assembly model SEMA. So from here, I can draw a conclusion that model SEMA plastics is a winner. So if I am the eco-designer for my factory, so I advise my manager to go for plastic instead of aluminium. All right, if we are only consider the impact from material extraction to product productions. All right. So now plastic is the winner. So this shows features number 6 compared to products in the production stage. Okay, now let's say if I would like to compare the life cycle of these two products, because now we are comparing the production stage only. What if we compare the life cycle of these two products? So I have to close it. Okay, to compare the life cycle, I have to go to the life cycle. All right, this is already pre-inserted for you. So a life cycle for SEMA, a life cycle for Pro. Okay, so before this, let's see what has been included in the life cycle of SEMA and what is included in the life cycle of Pro. Okay, in the life cycle of SEMA, which is made from plastic, so like just now, we know it includes the assembly of one manufactured product of this coffee maker machine, plastic, and then the electricity use consumption, 375 kilowatt hour, and then waste disposal, and then the use of coffee filter and use of packaging. Okay, let's see what is included in the life cycle of Model Pro. In the life cycle of Model Pro means no take back, so everything when it is broken is disposed. The manufacturer is not taking it back. No EPR, extended producer responsibility scheme involved. So the assembly is one unit of aluminium coffee machine Pro, and then the electricity 250 kilowatt hour as compared to just now 375. So for aluminium, the amount of energy consumption is lesser because it uses thermostat. Okay, so 350 kilowatt hour. And then on the disposal part, so it's used the same, it is from Netherlands. So it consider this, we call it this coffee machine, when it's broken, come to the end of the life, it is disposed directly to the municipality. The initial life cycle, there's no difference. They still use coffee filter, 650 units, and the use of packaging 1 unit. So basically the difference here is in terms of the electricity consumption and also the production. Okay, so just now we know production of plastic is totally the winner. All right, now let's see when we consider the whole life cycle, we already show the same result. All right, so in order for you to check, so we have to highlight these two in the folder of life cycle, and then we put a compare. We click on the compare button. So the compare button, I will still choose greenhouse gas protocol, and then let's calculate. So in this case, all right, so let's see. Now the dark green color is representing plastic. And then light green color is representing aluminium. So in this chart, it simply tells us that in terms of greenhouse gases emission, light green is the winner because it creates less impact, less carbon emission. Light green representing aluminium. So just now, the result is totally different from what we saw just now on the production stage. So when we include energy consumption, when we include other aspects in the end of life, so the result may be totally different. So in this case, if you are an eco designer who consider the life cycle of your product, then you'll make a decision that let's stick to aluminium. Because aluminium, in terms of life cycle, it generate less impact to the environment. For plastics, even though in the production stage, it is less polluting, but when it is consuming too much energy, when it is used by the consumer, so its environmental impact is worse than the aluminium coffee maker. So in this case, so as an eco designer, you know what to decide. Okay, so similarly, when you are doing comparison, you could create network. So you can analyze this table, you can do process contributions, you can analyze this. So once you got this, when you are reporting your analysis in your final report, you can actually export the table out. Okay, let's export this table out. Let's say I want to export process contribution. To export this, you just need to click on this page, and then on the file there, you see an export button. So just to click on export. So it will export it in your let me export it and locate it as my desktop. So you can save at type as text file or Excel. So for me, I'm using workbook sheet, and then just say that this is the result LCIA. So I'm saving it, I'm exporting it out in my Excel. So it is very tedious for us to actually copy or type it out 39 processes. So let's see what I got once okay, so my result LCIA, so I double click on it. So you will see. Okay, so this is basically exporting everything, 39 processes. So by using that, you can actually copy and paste this table into your final report, or you can do some further interpretation or analysis on your own by using Excel. You can create different type of chart or different way of presentation, which is appropriate for you. Okay, so basically this is how we export. We can also export inventory, 571 inventory. So same thing, when you click on this page, you just click on export. So you export into the same thing. Excuse me, inventory. So export it. So it will appear. Let me open it up. So you will see there are 571 inventories being included. Okay, so basically you can export every table or every chart that you want. Okay, so all right, so we have already completed features number 7, which is comparing life cycle. So now we are going to the last one, inspect or select a method. Okay, so there are a number of methods available for you. All right, so let's say I'm going to do only one, life cycle plastics. So I would like to analyze. Okay, so when I click analyze, so in the method, there are a lot of methods. All this while we are only looking at single issue methods, which is greenhouse gas protocol. Okay, there are many other methods which are developed by different countries, where they are looking into impact category that is more concern for them. Examples, on European, they use EDIP 2003, ecology scarcity, impact 2002 plus, CML, IA baseline. So you are actually free to try each and every one of it. Okay, so there are global one, so recipe, endpoint and midpoint. So endpoint, endpoint, they analyze it until the damages to human health, damages to ecosystem, and damages to resources. Midpoint, they are looking at only like substances, example, global warming potential, ecotoxicity, and also eutrophication, ozone depletions. Okay, so let's try global. Okay, recipe, their endpoint, midpoint. So I'm going to show you the midpoint first. Okay, let's choose midpoint hierarchies. So H. So instead of choosing a single issue, now we are looking at multiple issues. All right, let's see what are the impact categories being included in recipe. Remember, ladies and gentlemen, you are free to try out all methods, and then you'll find the appropriate one. Depends on the objective. What do you want to see? The objective is to analyze only carbon emission, then you do not need to choose multi-issue. You just need to choose a specific issue. If your objective is looking at energy only, then you choose energy issue. So if your objective is to look at the whole environmental impact in the in the multiple impact categories, then you will choose a multiple issues. So like recipe is a multiple issue. By looking at this table, you will see there are more than 10 impact categories that they involve: global warming, stratospheric ozone depletion, ionizing radiation, ozone formation, and then they are all acidification, eutrophication, a lot of things, ecotoxicity, and they're represented by different units. And this is only midpoint. If it is midpoint, it's only covered characterization and normalizations. All right. So similarly, because I was choosing the CIMA, the life cycle of a coffee machine, so it involved assembly, electricity consumption, the waste disposal, and the use of coffee filter and use of packaging. Okay, so it gives you a lot of ideas. So let's look at the chart. So when I look at chart, so every chart represents each impact categories. So by looking in this chart and overview, we know that most of the impact categories are contributed mainly by the light green color aspect activities. So the light green color is the energy. So energy consumption has contributed a lot to each impact categories except land use. For land use, the green color, the yellow color is the main contributor, where the yellow color is the use of coffee filter. Means the manufacture of coffee filter actually contribute a lot to land use. Okay, maybe it is biodegradable, means it has to have a lot of agriculture activities to carry on it. And marine eutrophication, because when you're doing a lot of agriculture, a lot of fertilizer being used, and this fertilizer runoff will contribute a lot to marine eutrophications, right? And then on the other two impact categories, which are the freshwater ecotoxicity and the marine water ecotoxicity, the main contributors are the waste disposal. All right, so when it's disposed to the landfill, and then the leachate may contribute a lot to the groundwater table, and eventually they flow into the sea and contributed to marine ecotoxicity. So this is what we see. So in characterization, we could not compare. In this chart, I could not tell you which impact category is more serious than the other one. So we can only analyze on every single impact categories itself. Example, we look at global warming, and then I can tell which one is the main contributor. And then on ozone depletion, which one is the main contributor. I could not compare global warming to ozone depletion until I click on the button of normalization. When I click on normalize, everything is normalized. So now the chart is different. We can tell, okay, in terms of impact categories, the main contributor of this life cycle is contributing to the category of marine ecotoxicity, followed by freshwater ecotoxicity, and then water consumption, human carcinogenic, and ionizing radiation. So the rest are actually basically insignificant. So in this case, on characterization, you see they are each impact categories are represented by different units. When they normalize it by dividing by person per year, and then you will have unitless value, and then it give you a total. So everyone have a total there. All right. So I would like to bring your attention to the value. If you see a value, some of the value is carrying a positive value, some of the value is carrying a negative value. All right. A negative value actually means good, a benefit. All right. Like example, the avoided product. When the avoided product is more, means it's created, means we are avoiding the production of some other product. So actually we are contribute benefit to the environment. So in this, in CIMA Pro or in LCA analysis, positive value means no good. Negative value means good. All right. The higher the magnitude of the negative value, the better it is, because it's contributing benefit to the environment. So in this case, if you look at here, so some of the chart has showing negative value. Because the negative value is too small, so it's not shown very clearly in terms of scale. All right, so that is okay for normalizations, characterization. So now I'm going to show you the same method, but instead of using midpoint, I'm using an endpoint. Okay, so the method, just now we choose midpoint hierarchies. Now I'm choosing endpoint hierarchies. So I select on the endpoint, so I calculate. So endpoint, it actually translates into a damages. Okay, so in this case, all right, so let's look at here. So in this case, the impact category are still global warming, stratospheric ozone depletion, and all this. All right. So you see, the unit is no longer how much CO2 equivalent. They have already translated into daily. Daily is disabled adjusted life year, and then if for species, daily is more for human health. The higher the value of daily means the worse it is. It means we will die earlier, we'll die faster. Okay, disabled adjusted life year. Okay, so species dot year means species times years. The higher the value means more species will go extinct times a year. All right, so this is representing the damage to ecosystem. The species can be flora or the species of fauna. And then for economy, for resources, is represented by monetary value, like USD value. So basically the units are three: daily, species years, and USD. All right, so these are the value. Okay, so when you look at endpoint, there are more choices here. Excuse me. So for midpoint, there are only characterizations and normalization. For endpoint, you will have extra damage assessment, weighting, and single score. Okay, so this is characterization. They characterize to the damage already. So damage assessment, you see that. So daily is for human health, species years for ecosystems, USDs is for resources. So once they normalize, means you can compare, and then weighting and give you a single score. Okay, so in this case, because you are here, all right, so it is the point. Weighting is mostly including the social perspective. Okay, so let's look at the chart. So on characterizations, similarly, you cannot compare on each impact categories. When you have a damage assessment, you cannot compare, so it just change characterization, link it, classify it into three main group of damages. Okay, at this moment you still cannot compare which one is more serious, either the impact towards human health, impact towards ecosystem, or impact towards resources. But in human health, we know that the green color one contribute the most. The light green color is actually the electricity consumption. Similarly to ecosystem, similarly to resources. Okay, so once you have a normalized result, then we know that the life cycle of this coffee machine contribute worse to human health damage. Okay, followed by ecosystem and followed by resources. So means resources is not the main concern, but human health is the main concern. Maybe due to the emission of some toxic compound, and also the release of leachate when disposal or during processes of component of this product, and also maybe the emission released during the electricity consumptions. So after we have included the weighting, okay, so on normalized there is no value. Once they include the weighting, so it will give you a point value. So it's still the same, it will not change much. So we come to the single score. Okay, when you come to a single score, it will tell you, okay, in which part contribute the most to human health, ecosystem, and resources. So there are 5 main parts of the life cycle of this coffee machine. We know that electricity consumption contribute the most environmental damages. Okay, in these environmental damages, mostly 80% is for human health, and then only 20% for ecosystem. Resources is actually negligible. Then on the use of coffee filter, it contribute the second highest damages, but in this second highest damages, mainly is human health. So as an eco designer, you know, okay, what you need to improve, which aspect you need to improve your coffee machine. You have to come up with a design of coffee machine which has less energy consumption, because the rest are not so serious in terms of environmental damage, but the electricity is the most serious part of it. So this analysis actually give an idea to either the stakeholders or managers or the owner of the factories or the products to actually make decision on how to reduce the environmental impact throughout the life cycle of the product and do improvement on it, whether it can be an R&D process or it can be a replacement of material, or it can be in terms of efficiency of the product. Okay, so that's it for this video. So let's summarize. So in this video, we have already covered analyze a full life cycle of a product, and then we compare two products in the production stage. We compare the two products in their life cycle stages, and then lastly, we inspect and choose different method for the analysis. So there are a few other methods that you are free to explore. So that's it for this video. So thank you very much.